Welcome to the new video of Explaino Tech. In this video I take you through the basic operating regions of hybrid vehicle and how this is dependent on the BSFC map. I will start with the basic comparison of gasoline and diesel engine BSFC map and how this is critical for deciding hybrid operation. BSFC, brake specific fuel consumption, stands for the fuel quantity consumed for a unit of energy generated. So higher the BSFC values, lower the efficiency. Unlike a diesel engine, a gasoline engine faces unique physical hurdles that dictate the shape of its efficiency contours, which is visible in the BSFC map. The low-load region of the map is controlled by the pumping losses and throttling. At the bottom of the map, low BMEP, BSFC values skyrocket, often above 350 to 400 grams per kilowatt-hour. This is primarily due to pumping losses. Gasoline engines generally control power by using a throttle valve to restrict airflow. When you are at low load, the throttle is nearly closed. Hence the piston has to work hard to suck air past that restriction during the intake stroke, creating a vacuum in the intake manifold. This negative work subtracts from the engine's output. This is exactly why hybrids use EV mode at low loads, to avoid spending energy just to move air past a closed throttle. Next, at the top right of the map, at the high-load, high-speed region, BSFC increases again. This is driven by the need to protect the engine's hardware. Low compression ratio in gasoline engines have low compression ratio, around 10 to 1 to 12 to 1 compared to 14 to 1 to 22 to 1 in diesels. A lower CR means lower thermal efficiency, but it's necessary to prevent knocking pre-ignition. Because the expansion ratio is lower, the combustion gases don't cool down as much before the exhaust valve opens. Gasoline EX can exceed 900 degrees Celsius, whereas diesels usually stay much cooler. To prevent the turbocharger and catalytic converter from melting at high loads, the EQ injects extra fuel. This liquid fuel evaporates and cools the combustion chamber. Since this extra fuel isn't burned for power but used for cooling, the BSFC increases significantly, the enrichment zone on your map. The center, island, also known as sweet spot, where BSFC is lowest, typically 230 to 240 grams per kilowatt-hour, occurs where these losses are balanced. The throttle is wide enough that pumping losses are minimized. The engine speed is high enough to reduce the time for heat transfer to the cylinder walls, but low enough that internal friction isn't dominant. The engine is not yet in the enrichment zone, staying at a stoichiometric ratio. The diesel BSFC map is fundamentally different from a gasoline map because of how a diesel engine manages air, fuel, and heat. While gasoline engines are throttled, diesel engines are quality controlled, meaning they always take in a full charge of air and only vary the amount of fuel injected. Due to no throttling, in the bottom region of the diesel map, low BMEP, the BSFC remains much lower than in a gasoline engine. The sweet spot in a diesel map is usually lower, around 195 to 210 grams per kilowatt-hour, than in a gasoline engine. Diesels operate at much higher compression ratios, 16 to 1 to 22 to 1. This follows the thermodynamic principle that a higher compression ratio leads to higher thermal efficiency. Also, diesels always run lean, more air than fuel. This excess air ensures more complete combustion of the fuel and acts as a working fluid that absorbs heat, reducing energy lost to the cylinder walls. While gasoline engines are limited by knock-in heat at high loads, diesel engines are limited by oxygen availability. As you push for maximum BMEP, top of the map, you inject more fuel. Eventually, there is so much fuel that it cannot find enough oxygen molecules to burn completely. This leads to the formation of particulate matter, soot, black smoke. To keep emissions legal, manufacturers cap the BMEP at a point where the air-fuel ratio is still slightly lean. This is why almost all modern diesels are turbocharged. By forcing more air in, they lift the smoke limit, allowing the engine to operate at higher BMEP levels, up to 20 to 25 bars, while maintaining low BSFC. This is a back-to-back comparison of BSFC plots of gasoline and diesel for an overview. Next we will try to explain how this influences the hybrid operation. This graph illustrates how a hybrid system hacks the traditional gasoline engine BSFC map to maximize efficiency. To understand it, we look at where the internal combustion engine, ICE, is forced to work versus where it is allowed to turn off. First, the EV operation zone. Here IC engine is off. Located at the bottom left, green box, this area represents low speed and low load, low BMEP. In a standard car, the engine is extremely inefficient here because of pumping losses. BSFC values here are often 400 plus. The hybrid system shuts the ICE off entirely. The electric motor handles the load. By doing this, the hybrid erases the most inefficient part of the gasoline map from its actual drive cycle. Second, the ICE operation, peak efficiency. The goal of the hybrid controller is to keep the engine operating in the sweet spot, yellow island, as much as possible. In a series hybrid setup, like a range extender, the engine doesn't even drive the wheels directly. It sits at one constant speed and load, the exact point of maximum efficiency, acting purely as a generator. If you are driving at a speed that requires only 4 bars of BMEP, where BSFC is high, the hybrid system will artificially increase the engine load to 8 bars. The extra 4 bars of torque is used to spin the generator and charge the battery. You are essentially buying fuel at the cheapest possible rate to use later. Third, combination operation, ICE plus EV boost. This is represented by the blue hatched zone extending above and to the right of the standard engine's limits possible with parallel hybrid mode, blue dashed line. When you demand sudden acceleration, the electric motor boosts the engine. Notice the max combination line. The electric motor adds torque on top of the engine's maximum capacity. This allows a small, efficient engine, like a 1.2L, to perform like a much larger engine, like a 2.0L, during overtaking, without the fuel penalty of carrying a heavy, large engine all the time. Now comparing this to the diesel map, if you recall the diesel map we discussed earlier, diesel is naturally efficient at low loads because it doesn't have a throttle valve, no pumping losses. Gasoline hybrids use the EV mode to mimic this diesel advantage. By turning the engine off at low loads, the gasoline hybrid achieves diesel-like, or even better fuel economy in stop-and-go city traffic. Now let us check why gasoline is always paired with hybrid. The reason hybrids are predominantly paired with gasoline engines rather than diesel comes down to a diminishing returns argument in thermodynamics and a harsh reality in manufacturing costs. The double cost penalty is the biggest barrier for diesel. To meet modern emissions, Euro 6/7, a diesel engine requires a turbocharger, high-pressure common rail injection, and complex after-treatment. A full hybrid needs a high-voltage battery, powerful electric motors, and complex power electronics. Putting a hybrid system on a diesel engine results in a vehicle that is significantly more expensive than either a standard diesel or a gasoline hybrid. Consumers are rarely willing to pay that double premium for a gain of only a few extra miles per gallon. While technical efficiency is a huge factor, the real driver for manufacturers today is CAFE, corporate average fuel efficiency norms. These are government regulations that don't just look at one car, but at the average fuel economy and CO_2 emissions of every car a manufacturer sells. And CO2 being directly proportional to the fuel burnt and hence the BSFC values. Hybrid tries to reduce the CO2 values for gasoline vehicles. The pairing of hybrids with gasoline engines is a strategic move to beat these norms. Thanks for watching. If you like the video, please share it to your loved ones. Please like and subscribe the channel.